Okay, here we go with lesson 7% and equations from geometry. 30% of what number? Okay, so we begin by writing 93 is equals 30%. Okay, if the percent is given, write it as a decimal. 0.3 is 30%. Okay, continue reading. Of means times. Of what number? Okay, and so of what number? I can call that x, I can call it n, whatever. Okay, of what number? In fact, we might want to just call that, let's call it n, because it's number. Okay, and so that's the setup, folks. And we're going to divide both sides by 0.3. Okay, if you're doing this by hand, we would want to notice that we're dividing by a decimal, so we have to move the decimal in the denominator, move it in the numerator as well. So 930 divided by 3. 310 is my number. Okay, next example, we have another problem involving 7,800 is what percent of 390? Okay, let's start by writing what we have to begin with. 7,800 is equals. And then what percent? So this time the percent is not given. We're actually solving for the percent. What I like to do is I like to write this as what is the x, okay? And then percent, I think of that as per means divided by, so I divide, and then cent means 100. What percent I can write as x over 100. Okay, I'm solving for what part out of 100. Let's continue reading. Of is times, and then of, so times 390. Okay, and let's turn this into a fraction as well. We have 390 divided by 100. Move the decimal over 2, so that's 3.9 x. 7,800 equals 3.9x. Divide both sides by 3.9. I probably would do this one in the calculator. Just stick it on in there and get x equals 2,000. Okay, keep in mind, when you're asked for what percent, you're actually solving for the percent. So your answer should include the percent. Okay, so plugging it back into the original, it would read 7,800 is what percent? Is 2,000% of 390. And that makes sense, doesn't it? Because if we have anything that is 100%, that's the total. Anything over 100% means quite a bit more, okay? And we see that 7,800 is in fact quite a bit more than 390. So our answer makes logical sense. Next problem, we're going to do some geometry. Example 3, find x, a, and b. First of all, let's see if we can locate x. All right, I see an x here in this angle down lower left, and an x here in the angle in the upper right. Okay, and so taking a look, looking at the picture, the structure of this actually should be marked. These are parallel lines. So we do have the parallel lines with a transversal setup. Okay, and so we know that these two angles, the x's, are congruent angles by alternate exterior angles, and we abbreviate that as A, E, A. Okay, and furthermore, we see that there are two small angles that are formed by the parallel lines and transversals, but we know that they must be congruent. Therefore, we can set up an equation that says just that. The angle that's labeled 2x plus 12 is equal to the measure of the angle marked 5x minus 21. Okay, so that's our setup. Let's go ahead and finish that. I'm going to put my x's on the right, and I'm going to move my constants to the left, giving me 33 equals 3x. Therefore, x is 11. Okay, so we solved for x. X is 11. Now let's solve for a and b. So looking at the picture, we have two small angles again. Okay, so we know that these a and b are going to be congruent. By what reason? Well, these are two alternate interior angles. So we can say here, let me get another color here. So we can say angle A, the measure of angle A equals the measure of angle B. Why? Because of A, I, A, alternate interior angles. And we could set those measures equal to each other. Problem is we don't know what the measure of either one is, but no fear, have no fear, because we also see that angle A, I'm going to color this in yellow, angle A and the angle right across from it, those are vertical angles, so they are congruent by vertical angles. Well, we just solved for x here, so if we want to know how many degrees that is, we just go ahead and plug it in. Okay, so what is 5 times 11 minus 21? So we would have 55 minus 21 for 34. Okay, each of these angles is 34 degrees. Okay, and so we would have angle A and angle B are both 34 degrees. Next problem, example 4. Let's read this together. The measures of angles A, B, C, and D are in the ratio of 1 to 2 to 4 to 2. Find the measure of each angle. Okay, so we're going to use some ideas from geometry to set up an equation. So what we do know is that if I add up all of these angles together, if I add all of these up together, if I put them together, they make a what? They make a straight line. Okay, so we know we're going to have 180 degrees. Okay, and so what do we do with this ratio? Okay, the ratios are given in this order. Okay, so what I'm going to do with this is I'm going to translate that in terms of ratios. I would say, and by the way, it's going to be in order, in the order given. So A, B, C, and D in the problem are in alphabetical order. So therefore, the ratio that's given is going to correspond in like manner. So what we have is A is going to be 1, I'm going to call it 1x. B has two parts, okay? So angle B has two parts, so 2x. Angle C rather has four parts for 4x, and angle D has two parts. Okay, and that's basically, once we find the measures of these angles, if you were to reduce those to lowest terms, they would reduce to this ratio here. 1 to 2 to 4 to 2. Now, obviously the angles aren't 1 degree, 2 degrees, 4 degrees, and 2 degrees. Okay, that's clear. But their reduced ratio would be 1 to 2 to 4 to 2. Okay, so we can use the idea that the 1, 2, 4, 2 is multiplied by some number, is multiplied by the same number, x, that was factored out to get that reduced ratio to begin with. So hopefully that kind of makes mathematical sense. And so all we have to do now is add these up. Okay, we're basically saying that, and let's start with, we can start on the left. So go in order of reading, okay? So we can say angle D, which is 2x, plus angle C, which is 4x, plus angle B, which is 2x, plus angle A, which is 1x. Okay, if I add all those up, like we said before, we should get 180 degrees. So add up all my x's. We have 2 and 4, that's 6. 2 more is 8. 1 more is 9. We have 9x equals 180. Okay, therefore, x is what? X is, looks like 20. Okay, well, are we done? Not quite. What does the problem ask for, guys? It says find the measure of each angle. Okay, so now we're going to go back. Let's do this in green. Okay, so if x is 20, we just plug that in to each angle. Well, A is 1x, so A is 20 degrees. B is 2x, so 2 times 20 is 40 degrees. C is 4x, so 4 times 20, that's 80 degrees. And angle D is 2x, so that's another 40 degrees. And you'll see that if you add up the green angles, you will get 180 degrees. Okay, there are a couple whiteboard problems. These are our practice problems that we normally do together in class. And I want to go over a couple of these. We can skip the percent ones. But since this is a new problem, let's see how we would tackle this. So this is going to be like, I believe, number 9 in your book. So take a look. What do we have here? We have a triangle. We have all 3 angles labeled. So they're kind of incognito, but they're all in terms of something with an x. I'm losing my voice, apparently. So start with what you know about the angles in a triangle. Okay, ask yourself, what do I know? Well, I know that if I add up all of the 3 angles, they should equal 180 degrees, right? That's the triangle sum theorem. Okay, so that says that angle A plus angle B plus angle C, the measures will equal 180 degrees. Okay, well, can we substitute now, you think? Sure, Ms. Pruitt, let's go ahead and substitute. All right, so angle A is 2x plus 2. Okay, so let's substitute that in. 2x plus 2 plus angle B. Okay, there's angle B, 7x plus 18. And we're just adding, 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 adding. We don't need any parentheses necessarily. Plus angle C. Angle C is 6x plus 10. And drop the equals 180. Okay, all right, and there you have a nice equation, but the key is getting this set up. And I trust you know what to do from this point. Add your like terms together. So let's add all our x's. We have 2 there, 7 there, and 6 there. Okay, so for 15, I believe, 15x. Okay, and then add our constants, 2 and 18, that's 20. And then 10 more for 30 equals 180. Okay, and then you have a nice simple equation to solve. 15x equals 150. All right, after we divide both sides of the coefficient, we get an answer of x equals, looks like 10. Okay, all right, so that one's done. Let's make sure we answered the problem, or answered the question. It said find x, all right? In some cases, they'll ask you to find the measure of each angle, but they didn't in this case. What would we do if we were asked to find the measure of each angle? Trust you know what to do there. You would just simply substitute back in. Everywhere you see an x, 10, and you could get the measure of each angle. You might want to do that just to make sure that they all add up to 180 degrees. Okay, and I did want to go over this problem with you too. Okay, since this is also new, and you're going to come across this in your homework set as well. And it reads like this: find x, then find the measure of a small angle and the measure of a large angle. Okay, guys. So here's what we do know. This is a little intimidating, but we do know that anytime we have parallel lines and a transversal, that we have special angle pair relationships. So we do have parallel lines. In fact, we have a lot of them, right? We have 4 of them. Okay, so what I want you to do is just kind of, what if we ignore these? Okay, what if we ignore those, just pretend that they're not there? Does that simplify it? Then I have 2 parallel lines, okay, and I have a large angle and a small angle, okay? Well, what do we want to do with that? What do we know? We know that they're definitely not congruent because I got one obtuse and one acute. But what I could do is I could move this, let's say, this small angle. This small angle, remember all the small angles are the same, aren't they? So couldn't I move that up to the upper right and say this small angle here, well, that's congruent to this small angle down at the bottom. Okay, and hopefully you'll say, well, yes, that makes sense. And furthermore, we know that, well, it looks like, lo and behold, if we put a large and a small angle together, they make a straight line, don't they? So a large angle plus a small angle will always equal what? How many degrees are there in a straight line? 180 degrees. Okay, so that's the key to solving this problem. We've got a large angle and a small angle, and in this orientation where you have parallel lines and transversals, a large angle and a small angle will have a sum of 180 degrees. Okay, and so let's use that idea and set that up in an equation. All right, let me get green. Okay, my large angle is 4x plus 33, and my small angle is 3x. And they should add up to 180. Okay, and then you have a nice simple equation to solve. We've got how many x's? We've got 7 x's, it looks like, plus 33 equals 180. Subtract 33 from each side. We get 7x equals 147. Does 7 go into 147? Gosh, I hope so. I think it does. Yeah. 7 goes into 14 twice and then into 7 once. All right, so here we go. Let's answer the problem. First, we needed to find x. Okay, and so we did. X equals 21, and then we needed to find the measure of a large and a small angle. Well, here we go, folks. We know what x is, so let's go to the large angle and substitute in times 21. Okay, so we're going to have 84 plus 33. Okay, for 117. So the large angle equals, what did I say, 117 degrees. Okay, and the small angle is 3 times 21. Okay, so we're going to substitute 21 back in there. We have 63 degrees. And if you did add these two up, a large and a small, do they equal 180? 6, 7, 8. Yep, they do. So it all works out. A large angle plus a small angle equal 180 degrees. Okay, folks, I think that's it for this lesson. So we got some good stuff talked about. We did some review of percents, and then we also learned some new methods, okay, to solve some more geometry problems. All right, I hope you guys have a wonderful Labor Day weekend, and I will see you in class Tuesday or Wednesday. Let's see, that's for if you're in periods 1, 2, 3, or in class if you're in my period 6. I'll see you on Thursday or Friday of next week. Okay, make sure and email me or send a message in the chat if you have any questions over the weekend, and I'd be happy to help you out. Okay, bye now.